Well, hello friends. Welcome back to the program. Today we're going to play another round of FIXME Roulette, the game where we grep for FIXME and to do and then try to fix whatever comes up, or at the very least make some progress on it. We'll see, depending on what it is. But basically we grep for to do or FIXME, and then we shuffle so that we get only one result, and then the main rule is that we have to have a net negative number of FIXMEs in the code base at the end of the video. So today's task is going to be in libcpp parser, line 1020. 1020. Oh, wait a minute. If token text is to do or FIXME. This is checking for to do or FIXME in our C++ parser. So I think this is a false positive. Let's try that again. Okay. Kernel Syscall's Fallocate. All right. Fallocate. Line 54. That was pretty funny. Line 54, enospisa. There's not enough space left on the device containing the file referred to by fd. Okay. So in the fallocate syscall, we are missing, I guess, handling of disk full. Okay, well, that's definitely not something that we test often, so I guess now we gotta suck it up and write some code to handle disk full. That will be healthy though. I feel like that's one of those things. I even talked about that recently, I think on office hours, about how disk full is one of those errors that that people rarely, if ever, test for. So how do we even check that this doesn't work? I mean, I guess we can just fallocate until we run out of disk space and then see what kind of error we get. So we're going to need a test program for this that we can run inside Serenity. So I guess we can make something. We can call it fill. We're going to fill the disk here. Yeah, this will be okay. And then let me just go ahead. This is just going to be a temporary testing tool at this stage, but I'm going to go ahead and add enough to it that I can write a simple program. So fill.cpp. Okay, we'll just make a Serenity main arguments, all the usual stuff. And then what do we want to do here? I guess we just first cut, let's just fill up the disk with files. So easiest way to do that, either make a lot of files or make one really big file. This actually makes me wonder, do we have DD or something like that? I feel like we do have DD, right? We do have DD, so I could potentially actually use DD to fill the disk. Okay, maybe I don't need to make a fill program. We need to make a test program of some type, so might as well call it fill. But yeah, DD dev0, and then OF is going to be my file. We'll do megabyte at a time, let's say. And how much disk space do I have here anyway? I have 812 megs available. I mean, it's probably easier to just use the temp file system for this kind of thing. Although that one doesn't know, it doesn't know how much is available, but it shouldn't matter. So let's see, what if we make 100 of these? Well, that gave us a 100 megabyte file, I guess. Oh, but it's not, it's probably lazily allocated. So we would need to actually get some dev random up in there to actually use the memory. Yeah, otherwise I was gonna say it's just gonna be 0 pages, but wait, there's stuff in there. Why am I not seeing this down here? Oh, maybe I am. Does this graph even work? Did this graph break? It's supposed to have like a little bit of blue. Why is it so small? Maybe I need a lot more. Let me make a gigabyte, or yeah, let's make a gigabyte instead of random. Okay, yeah, this thing is starting to grow up a bit. Just wasn't really visible before because of how we have 4 gigs of RAM on this machine. Okay, yeah, I just remember running in the past with like way less memory for the system. Okay, so let me try to make a second file, my file 2. I'll just pull from dev0. And then we'll also find out if that actually does lazy pages somehow, but it seems like it doesn't because it just blew up to half full there. And another file, and then the very last one, we should run out of memory here. Cannot write to the output. Okay, so it fails to write. Now we are super full, or near super full. So let's see, we could probably do this because the temp directory is obviously going to get blown out when we reboot. And then the kernel got mad because, yeah, we tried to do something and we didn't have memory. Yeah, it's still not super good at handling that scenario. So let me make a huge file in my home directory so that we at least don't fill up /temp, which makes the kernel a bit mad. So we'll just make a file, we'll call it big, and it's not even going to fit, I think. But I think DD will just keep writing until it gets an error. In the meantime, we can figure out what to do with Fallocate. So Fallocate is in fcntl, also known as fcntl.h. There we go. Okay, so fda is going to be open. We'll just open a file called foo. And we are about to read, write, not truncate, actually, allocate. Fallocate. Wait, what is Fallocate? I'm confusing it with truncate in my head. Fallocate. Fallocate, pre-allocate or deallocate space to a file. I see. So it's not like truncate because it doesn't actually change the file size. It just pre-allocates storage. It's a non-portable Linux-specific system call that we apparently implement. Oh, Posix Fallocate. Wait, is this a thing? Posix Fallocate. Posix Fallocate. Okay, it is a thing. All right. The Posix Fallocate function shall ensure that any required storage for regular file data starting at offset and continuing for len bytes is allocated on the file system storage media. If it returns successfully, subsequent writes to the specified data, file data shall not fail due to the lack of free space on the file system storage media. Cool. Yeah, so you front load your enos basically. Fallocate can give you eno space, but subsequent writes, as long as you stay within the bounds established by your call to Fallocate, subsequent calls to write will not eno space. I guess that makes sense. Okay. But we truncate here. Oh wait, if offset plus len is beyond the current file size, then Fallocate shall adjust the file size to offset plus len. Offset plus len. So it does adjust the file size. Space allocated via Posix Fallocate may be freed by a successful call to truncate, for truncate that reduces the file size to a size smaller than offset len. So if you allocate to a size smaller than the size is currently, then that's a no op, I guess. Okay, yeah, so if the file is already larger. Okay, fair enough. That seems okay. So let's see. Yeah, now we have filled up the disk. We have 740 kilobytes available, so we should be able to Fallocate our way into a problem here. So Posix Fallocate fda. So let's try a megabyte, I guess. Actually, why don't I use core system? Okay. I wonder if core system has a Fallocate. It doesn't. Not yet, anyway. Okay, so let's see. If RC less than 0. Yeah, let's just try to learn a little bit about what's going on here. So this is our problematic code, and then let's print something like unable to Fallocate. I mean, pair, actually, that's good enough for that. Fallocated. Okay. Let's see how this goes. So we should now have a large file occupying all the space. Right there, big. We have 744K available. If we run fill, open, no such file or directory. Right, I have to remember how to Unix. Gotta create that file. Okay, Posix Fallocate, success. Not an error. Wait, what? Posix Fallocate, success, not an error. What the heck? So did Fallocate return? Wait, what? Success, not an error. It returns 0. What am I missing? Posix Fallocate does not set error now. Oh, really? It shall be returned to indicate the error. All right. Wow. Yeah, okay. It's one of those modern Unix syscalls that doesn't set error now. Okay, well, that was a little bit surprising, but it's all good. We will simply say if it's not 0, then I guess we will have to warn line Posix Fallocate stir, something like that. But I guess we'll find out what the error is once we try to print it. Open permission denied. Okay, right. So, one more time. Unknown error. This is going so. Dang, what's going on here? Star RC. I gotta print out the code then. Let's see. O creat, O trunk. Permission denied. Why can't I? Oh, the perms are all goofed because I'm forgetting the I'm forgetting the third argument here. Let's just 777 that thing. Wow, it's been a while since I wrote this type of code, huh? It's just been flying around in the browser land. Okay, so now if I delete foo, there we go. Error -28, unknown error. So the error is actually backwards. So I think Fallocate here in the libc, this is probably wrong. We still need to invert the error code that we get from the kernel because the kernel always returns error codes, negative error codes, right? So you get an error no and then it's negative. So we do have to tweak that. Here we go. I think that will, at the very least, tell us what the error is. This was not a FIXME, but it's a collateral damage. We're also fixing other stuff. No space left on device. Hey, I was told that was not going to work, but I just got no space left on device. So I'm guessing that truncate probably does that internally. So let's see. So let's look at ext2fs inode truncate. Okay, so it tries to resize. Sure. And looky look. What is this? Here's one no space condition. That is if the size is greater than a U32 can fit, then it's no space. Here, if we need more blocks than the super block says we can accommodate, it's no space. So I guess we don't need to fix this. That's very nice. So no space is taken care of by truncate. That's good. So we still got a fix in here though. I mean, we get two fixes. We remove a FIXME that we don't need to do anything about. And we also fix the libc wrapper for Posix Fallocate so that it actually inverts the error code so it's understandable by the caller. Very cool. So let's see. This is kind of a little bit simple today, but still kind of interesting. Okay, so let's see. Let's do the libc change first. Okay, Posix Fallocate, and what kind of errors did it have? We could make a little test that just exercises the function and verifies that it can fail. Do we have something like test Fallocate? Does anybody call Fallocate actually? Posix Fallocate. It doesn't really seem like anybody's calling Fallocate. Okay, well, we'll make a test for it. Let's be good boys and farm some good boy points. Tests kernel test Fallocate. Test Posix Fallocate. Let's call it that. Yeah. Or does this go in libc tests, I wonder? It doesn't feel like it necessarily. Because this is a kernel functionality, right? So let's put it there. Okay. LibC. Return invert error codes before returning kernel. I guess we are negating them. Negate kernel error codes before returning them in Posix Fallocate. Yeah, so since Posix Fallocate doesn't set errno, like most other, or it doesn't set errno, it has to make sure to manually unwrap the error, any error from the kernel. Yeah. I think that would be okay. Does it return anything else other than that? Shall return 0, right? Yeah, so that should be okay. And then in the syscall file, kernel remove unnecessary FIXME in Posix Fallocate. This syscall doesn't have to worry about, doesn't need to do anything for enospc, as that is already handled by its callees. Yeah. So that's good. And then now we're going to add a little test, right? So test Posix Fallocate. Let's see. So let's get lib test casse. Posix Fallocate basics. And then, you know, I'm just going to go ahead and add a lib system or a libcore system wrapper, because it is, after you get used to these, it's so annoying to use the regular ones. So let's just make sure that we, this gets built on other systems like Mac OS and Android and stuff. So let's just make sure that it goes in one of these Serenity areas. Do we have like a nice one somewhere? Why are these separated? Okay, I don't know where to put it, so I'm gonna make my own down here. This is an error or void Posix Fallocate, and I'm providing a file descriptor. And what were the other two? It was an offset and a length, right? Posix Fallocate, two offts. I think those were the ones. Yeah. All right. So let's go ahead and implement that, because it'll be much nicer if we do. So let's see, int rc is syscall, or no. Or, well, we know we are on Serenity, but even so, we can still just do this. So if rc is non-zero, then return error from syscall Posix Fallocate RC. Yes. What don't you like about that? Oh yeah, of course I have to say that it's in the global namespace. Okay. And then we just need to return void like that. Perfect. So let me check with my fill program if I can write this in a nicer way now. So like core system. Yeah, so now it just becomes like that. The try macro together with the core system helpers really makes this kind of stuff a lot nicer, where you don't have to do all the error handling everywhere. So let's see how this, that's a big change in terms of rebuild. What did I touch? Oh, I touched system.h. Okay, well, I guess I deserve this rebuild. Okay, so let's just add that helper in the meantime. libcore add core system Posix Fallocate. Yes. Okay, so now for our test. I guess we can... do we have something for making a temp file? Temporary file? Temp file. Core temp file. This sounds like something I want, kind of. Okay, let me try to use that. Core temp file, create. Okay, what can I do with it? It has it's a temp file and it has a path. When did we add this? Itamar. I guess it's a while ago. Yeah, this is definitely an API that we could improve, because I would expect if I say like create a temp file, I expect the thing I get to be a temporary file of some type, not a thing that carries a path. That's a little bit strange. So yeah, it's an API we can do better, but I guess I can still use it just to get a path. Oh, hello. Posix Fallocate. Oh, unknown error. Back again. Right, minus 28. So wait, did I just not do that right? In libc? So Posix Fallocate. It now does a minus here. And the system wrapper. Oh, I have to negate it back. Because I think this thing expects a syscall input. Right. So it expects a raw thing that you would get from the kernel. So that's a little bit of a goof there. But no big deal. No big deal. We will just fix that up. Okay, that should be fine. And then let's get back on track with this thing. Temp file. I just need a temp file path. So fd is try. Okay, I don't want to use this API. It just feels so weird. Let's just do it the simple way. So, oh, maybe we have mk temp or something like that in the core system. mkstemp. There we go. Okay, so Posix, Fallocate, something like that, right? Wait, what did it want? It wants a span of char. You don't like this because? You don't like that because? Oh, it says a span of U8. That's kind of funny. So how do I make a span of, where's somebody using this? Okay, that's not very ergonomic. The fact that I can't just give it a string view, because string view hands out, string view is convertible to span of U8, but not span of char. So I have to make my own span here. So like span char, or span, so let's figure this out. Oh, I guess because it has to be writable. That's the issue, because it's going to write into this buffer. Okay. So you don't like this because it's a function that does not return error, sure. So we'll verify that fd is greater than or equal to 0. Okay. Can we fallocate something? Posix. Let's fallocate nothing, or let's fallocate a kilobyte. Why don't we? Okay. So what's the best way to write a test for something like this? I just want to test some of the random error codes, basically. So result here, expect. Result here should not be an error, right? So expect EQ, this should be false. And the value should be 0, not 9, 0. Or no, it returns void. So there's no value. Okay, and then if we give it an invalid file descriptor, by the way, that should be an error. And if we ask for the specific error, it should tell us ebadif. So error code should be equal to ebadf. Can we test stuff like that, I wonder? Let's see. And then we should also be able to ask for like something obnoxiously large. So user tests, kernel test, Posix Fallocate. Okay, so that worked. Let's just make sure that the test is functioning correctly by asking for the wrong error code as well. Okay, yes, good. So we could ask for something like a very, very large size. What would be the best way to ask for that? Ask for -1, I guess. Something like this. That should give you eno space, I would think. Because it will be the largest possible size we could ask for. Space? No, that didn't work out. Okay, so what did we get instead? It doesn't tell us what we get instead. Right, because it doesn't print out the error code. I mean, we got 22 actually. So what's 22? Invalid argument. Oh, because it's a negative number probably. If we look einval, yeah, if offset or length is less than, offset less than 0 and length is less than or equal to 0, that's einval. Einval, yeah. So it's matching those. So we could actually have those in the test as well. This should be einval. The same thing actually for length 0 should be einval. And offset -1 there should also be, I mean, we can just do it this way actually. No need to be fancy. This should be einval as well. So it's a bit tricky, like how do we have a number that would give us space? What's something? Can we open dev full for writing, I wonder? Dev full. Dev full is supposed to be this device that gives you space no matter what. Let's try that out. That would be really handy actually, because that's kind of what it's for. It's for just for testing full file systems. So Fallocate when disk full. So that's read write. Sure. Actually, we're not creating, so we don't need this. And then let's try to write anything. Let's try to Fallocate. Fada. Try to Fallocate 100 bytes. That's not a must situation. Okay, and then we should expect this to give an error. And we should expect the error to be space. All right. Let's see if this works. Line 52, that did not work. We got error code 9 instead. Bad for the number. Oh. Wait, what? I got bad for the, but this thing succeeded. When do you get bad for the? Oh, if it's not writable? But I opened it writable. Let's see. Is this what we're getting? Ebadf because not writable. I'm just checking if that's the ebadf we're getting. No. We're getting it. Okay, why is it ebadf? I guess I don't. Wait. So what's the file descriptor then? Full FD. Let's log it. See what we say the FD is. Wait, what? FD5. So why is it eBadF? If it's open, I don't understand. Okay. Let me just, let's see, full error. Just log the raw error here. So now I'm getting a little bit suspicious. Like, where are we getting that eBadF from? Full error 9. Okay, so we are getting 9. Bad for the number. Posix Fallocate. We are passing in the file descriptor, sure. I guess we can go here and check. On FD, just verifying. Okay, FD was available. I don't know. Are we not clearing this line here is what I'm wondering. It's like, are we closing the file? But why would we be? FD5 was available. Okay, so we get past this point. Was writable, let's say, okay. Where else would we get stuck then? Only in truncate, I guess. Is truncate or stat? No, Oh, stat could give us eBadF. Stat could give us eBadF. Why would stat give us eBadF? That's the virtual base class implementation of that thing. Okay, we'll find out in a moment. It was writable, so either we're failing in stat or somewhere. Yeah, I'm just gonna printf all the way here. Was statable, let's say. Being truncated was truncated. Yeah, so printf all the way. Just tell me why. If the problem is that stat is failing, then I wonder what kind of file this is. Oh, maybe the full device. I guess we're trying to stat the full device. It was writable, but it was not statable. So what the heck happens when we stat a full device? So I didn't think about that. It doesn't override stat. Is stat a thing? I don't remember. Stat. Okay, so it has the file base class stat thing. So you can't stat a full device. I mean, that just seems not right. Why wouldn't we let you stat the full device? So it's just something that we're missing. You can't stat the full device, and so Fallocate fails. Why does Fallocate fail? enodev. It should be enodev if it's not a regular file. Oh, is that what it's trying to achieve? Yeah, it's trying to do an enodev if it's not a regular file. So I guess we should be failing with enodev actually, but we're failing with eBadF because file objects in the kernel that don't have an implementation of stat, they just return ebatf. So there are like multiple sub-FIXMEs here. And we're not supposed to add new FIXMEs in these videos. So what do we do? I guess. Well, we need to figure out if this is a regular file. So can we just ask you, are you a regular file? Can I get metadata or something? File dot. I can ask it if it's all of these different things. Like, are you a block device, character device, blah, 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 whatever. That's interesting. Should we have a is regular file thing? What does this block device do actually? Oh, so so who would actually be a regular file then? I guess is inode. That's the only regular file. Everybody else is like special. So is inode is the thing that answers that. So we could change it this way. Turn inode dev. But that breaks our fine ability to test with dev full. So I mean, that was never going to work in the first place, I guess, because it is not a regular file. So much for that. Dang it. Dev full regular file. Is this a thing that other people have been annoyed by? Well, maybe not. I don't know. But we can totally do this. I think that's the better way to check if something is a regular file. Just check if it's a regular inode file, basically, because otherwise it's something else that's not a regular file. Maybe we should, I'm wondering if we should rename inode. So is inode means that this file subclass is, the file subclass in this case is inode file. Now I'm thinking like, would it be better if this would be called regular file instead of inode file? I don't know which one is more descriptive, but let's see. I guess we can, while we're here, oh, newer edition exists. Let's make sure we have the newest edition. So while we're here, let's put some spec links and stuff. Okay, so this is inodev, which means inodev, the FUD argument does not refer to a regular file. Ain't that the truth? Okay. Yes, let's commit that as a separate fix. Oh, dang it, that was the wrong file. Okay, first that separate commit, so, or no. Back up, calm down. I want to just restore. I just want to restore this file. Okay. All right. So the thing I want to do is make this fix. Yes. Just this one little fix. The FUD argument does not refer to a regular file. Kernel. Make Posix Fallocate fail with inodev on non-regular files. Previously, we tried to determine if the refers to a non-regular file by doing a stat operation on the file. This didn't work out very well since many file subclasses don't actually implement stat, but instead fall back to failing with ebadf. Yeah. Also, what's up with these backticks? Okay. Yes. So this patch fixes the issue by checking for regular files with file is inode instead. Okay. So we should be able to incorporate that into our test. So this thing here should not be giving us ebadf, right? But this thing should be giving us enodev at this point. Fallocate on device file. Yeah, we'll just pick dev0 because it's doesn't make it look like we're trying to do this with the full thing and failing. enodev. I wish I could use dev full and get the space error, but it seems like that would be a Posix violation if I read this correctly. Okay, and then I guess we could also add some more annotations here. It's like ES pipe. Yeah, we can just add these just because it's nice. ebadf. File that was opened without write permission. Yeah, look at that. This one will be handled by implicitly in here. These guys, E and Val, they're all up here. Yep. Yeah, we'll do that. Yes. Okay, so now the test works. So far, so good. We're probably not going to make the most exhaustive test here today, but it's nice to at least have something that just tests the API so that if you remove the API, we would notice that much. Kernel, add some spec links and comments to Posix Fallocate. Sure. Yeah. That's good. Okay, well, I think we're gonna be happy here for today. So it's annoying that we don't have a good way to quickly create, like, programmatically create a file system that is full. Now I'm just wondering if that could be a thing, but I don't know. Well, we'll have to think more about this one. But for now, let's at least take these two, take this little test program here, and then we can add more tests. And if anybody feels like adding tests, you know, there's always room for more. Tests. Add a very simple test for Posix Fallocate. I guess, I mean, we should probably test that the size of the thing actually changes. I feel like, so we've changed it here to 1024 here. This succeeded. So if we do a stat, we should verify that the size of the file is correct afterwards. So let's do that much at least. So core system stat. How do I stat it? Just like that? But what if I want fstat? I can. Cool. And then expect EQ result. I mean, this is not a result actually. So expect EQ stat dot size should be 1024. Just basic verification that it actually changes the size of the file. Yeah. All right. That's okay. That's okay for me for today. Okay. So something to think about for the future is like, how can we, in a non-brittle, non-fragile way, create a testing environment where we have a full disk device. I don't know exactly how to do that, but it's something that we'll definitely have to come back to. And perhaps if you have ideas, then speak up. I'm definitely interested in solutions to that kind of thing, because it would be a good thing to start testing more in that scenario. Anyways, this was another episode of the FIXME Roulette. So I hope you enjoyed the format. I'm glad that we were able to take a random FIXME, and even though the FIXME itself wasn't even necessary, we managed to find other things to fix. So it's all good. Thank you so much for checking out the video, and see you next time. Bye.